Today we're going to factor binomials that are not differences of squares, but they're in fact sums or differences of cubes. And I'm going to actually create a new page here. A sum of cubes. Perfect cube just means that it's either a letter to a cubic power, which means it divides by 3. Third power, 6th power, 9th power, 12th power, 15th power, 18th power. Any one of those is a cube. Anything divides by 3. Or if it's a numerical value, 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000, 1331, 1728, and so on. All right. 1 cube through 12 cube there. If you want to memorize those, you're welcome to do that. Anyway. Perfect cubes are numerical cubes or a cubic power divides by 3. If you have a sum of cubes, the factored form is first parentheses cube root plus cube root. So whatever the cube root is, divide the powers by 3. If it's a number, that's 3, 4, 5, 6, and so on. So cube root of each number. With the same exact sign. The second parentheses is a trinomial, and you're going to get 3 pieces, piece 1, piece 2, piece 3. For a plus, it goes like this. Plus here, minus here, plus here. Same sign, opposite sign, plus. Same, opposite, always plus. This is always plus, it's never minus ever, not even once. Always plus. You might think, by the way I'm saying this, that people sometimes put minus there because they do. They should always put a plus there. But this is the same sign, this is always opposite sign, this is always plus. To get these 3 pieces is very, very simple. Whatever this is, you square it. Whatever both of these are, you multiply them together. And whatever this is, you square it. That's how you factor a sum of cubes. Factoring a difference of cubes looks like this. A cubed minus b cubed. 3 pieces, 2 pieces. Alright, piece 1, piece 2. Cube root, same sign. Opposite sign, always plus. This is just going to be this thing squared. This is just going to be this times this. And this is going to be just that squared. The same pieces are in both, right? Yeah. A squared, AB squared. What changes is signs. Plus, minus, because that's plus and that's minus. Minus, plus, because we changed the sign on the second one. Plus, because the last one's always plus. That's how you do it. Simple. All right? It's a pattern. You recognize the structure, you apply a pattern, and you get the factored form. If I look at example number 1, x cubed y cubed minus p cubed. Investigate each piece to the third power cubic. Third power cubic, third power cubed, it being subtracted. Now remember, difference of squares had to be a difference. For cubes, it can be a plus or a minus. All right? Once I see it's a cube root, or cube minus a cube root xy, cube root p, same sign. Second parentheses, square the first object. If you square xy, that's x squared, y squared. Change the sign. Multiply the 2 objects together, xyp plus, always plus. Square the second, p squared, there's your answer. That's how you do it. Okay, I've been doing this for 27 years. Ish. 30 years. 30 years, yeah. I'm pretty quick at it, okay? You guys haven't done this, you've been looking at this for about 6 minutes now. So, I got a little more experience than you, so obviously for me it's easier. But the fact is, you practice the skill, you recognize the structure, you apply a pattern, you get the answer. That's how you do it. There's not really showing work to this, it's recognition and writing the answer. So what you're going to do is you're going to find places, hopefully, where you don't find places you mess up, but if you do mess up, you'll find out where you're messing up. If you mess up today, you're going to continue to mess up for the next several weeks on the same thing. So if you start messing up, if you start getting wrong answers, investigate why you're getting the wrong answer and really pay close attention to that as you're doing these until you get to the point where you're not messing up anymore.